Okay, so hello everyone. Thank you for joining us. We are going to discuss today a major vulnerability that we found that threatens hundreds of millions of Android devices and enable an attacker to take full control of your mobile device. This vulnerability will work on any Android version, and we are going to show you both live demo. And in some scenario, the attacker could take control of your device using a single text message. So let's see what we are going to discuss today. So we are going to discuss briefly about mobile threat and what gave us the motivation for this research. We're then going to discuss what is mobile remote support tool and what makes them unique. We will show you what it means if someone were able to get control of this tool, and we will finish with conclusions and Q&A. So before we start, we would like to introduce ourselves. So my name is Oad Bobrav, and I have more than a decade of research in the mobile cyber space. I started in feature phone and later on moved to smartphone. I was the former CTO and co-founder of Lacoon Mobile Security, which was acquired by Check Point a few months ago. And I'm now leading the mobile threat prevention area at Check Point. And I presented in many conferences, Black Hat, InfoSec, and other security conferences. With me is Avi.
Hey, I'm Avi Bashan. I'm a security researcher now for more than a decade. Started in the PC area and later moved to mobile. I was the CISO and a security researcher at Lacoon, and now I'm leading the security research at the mobile prevention area, threat prevention area in Check Point.
Okay, and we also would like to thank a few major contributors, Pavel, Daniel, Andre, and Denise, which were a tremendous help to this research. So let's get started. So I'm now going to discuss about mobile remote access Trojan, or an MRAT. So an MRAT is a tool that can be used by an attacker to take full control of your device. And once he was able to infect your device with this kind of tool, he can basically do anything. So he can read your email, your contact, your text message, and he can also use the sensors of the device. So for example, he can use the GPS to track your location. He can use the microphone to listen to the call happening in the room. And there are many known types of MRATs. So you have the low-end vendors, like Mobistel or MSpy, that you can just go online and purchase them for $100. You have the high-end, like Hacking Team, which was in the news lately because they got hacked. And actually, it was quite amazing to see how much information they were able to collect for mobile device. And you also have Dendroid, which is an infrastructure to create your own MRAT. And of course, as a leading mobile security company, it's very important for us to be able to detect unknown type of MRAT. And in order to do so, we are running a series of engines on any application that we are able to collect, or we are stumbled upon, in order to collect different capabilities. So, for example, when you look on an MRAT, you will see that among other, a regular MRAT will be able to install other application. He will be able to read your screen. He will be able to simulate user input. And because all of these actions are not an action that every application can do, he will usually use an exploit or root the device in order to do all of that capabilities. And what we are doing, we are classifying, according to capability, all the application to the type of malware that they are. But what we saw that for some reason, there was another group of applications that has very, very resembled capabilities to the MRAT, but somehow it didn't use an exploit to do all of these actions. And this group of applications is MRST. And what is an MRST? MRST is a mobile remote support tool. This tool is a tool that's being used by the support guys. For example, if you have an issue with your device, you will call your IT department, the mobile carrier, the device manufacturer, and they will use this tool in order to help you troubleshoot your problem. So for example, they will need to see your screen, they will need to take action instead of you, and so on. And there are many big vendors that provide this kind of tool. You're probably familiar with the names that are on the screen, LogMeIn, AllSupport, TeamViewer, Citrix. All of them has a PC component, and now they also have a mobile component to help you troubleshoot your devices. And let's discuss a little bit about the mobile remote support tool and understand how it works. So before I continue, I would like to take a step back and discuss a little bit about Android. So Android is a modern operation system, which means that every application is running inside the sandbox. And in order to get access to other resources on the device or to other application, it needs to obtain permission. And what is a permission? Permission is something that the application needs to declare in its manifest. And when the user wants to install a new application, he will get a list of all the permission that the application requires. And currently, it's a take it or leave it approach, which means that the user can either choose not to install the application, or he accepted and installed the application without the permission. Google improved the mechanism a little bit in the next version of Android, but the main principle remained the same. And what is the problem with this approach? Let's say this is an application, a flashlight application that I downloaded from Google Play. And as you can see, although it's a flashlight, for some reason it requires access to my location, to my photos, to my files, to the internet, and there is no clear reason why it should have it. But as we all know, users just tend to press accept and move on with their life, just forget about what they just installed on their phone. Besides the regular permission that every application can request, there is another set of permission, which is called privileged permission, that usually only system application can obtain. And a couple of examples are the ability to install other application without any indication to the user, being able to read your screen, and being able to simulate user inputs. And because these are a privileged permission, only an app that was signed by the OEM certificate or that was pre-installed on the device at the system folder are able to obtain this permission. And when you look on an MRST tool, so you will see that they have all the regular permission, so being able to access to the internet, to the device storage, and other regular stuff. But in order to really work properly, they need exactly this privileged permission. Okay, so the ability to install application, screen, and simulate user inputs. And how this MRST vendor were able to obtain this permission. So let's discuss a little bit about the Android customization chain. So Google created the Android open source project. It's then been taken by the different OEMs, for example, LG, Samsung, and others, and they compile their own version of Android with their own pre-installed app. Then the carriers take this version and they create also their own version of Android with their apps on it as well. And what the MRST vendor did, they collaborate with the different OEMs and carrier and convince them to sign the app and the code that they created with the OEM certificate, and therefore enable them to get these elevated permissions. And what we did, this is caught our eyes because what we saw that there is a shared party application that has a system right permission, which is something that is not a standard in Android. So what we did, we investigated many MRST applications in order to understand the architecture of this kind of tools. And what we saw that all of them currently have the same basic architecture. They will have a plugin which was signed by the OEM and therefore is able to obtain the privileged permission. And this application is running in the background. Usually it won't have any user interaction and user indication that this app is even installed. And it's actually working as a background service. So it takes commands from other applications. The second application is what we call the main app. The main app is signed by the MRST certificate, And it has regular permission, so it will have access to the internet, it will usually have some kind of user interface, and the way that these two applications are communicate with is through the binder. A binder is the native Android inter-process communication mechanism. But what was interesting for us was that we knew that there is no native way in Android for an app to verify the other app identity. Okay, so it's time to think, what does it mean? So what do we know so far? We know that we have a plugin that was signed by the OEM and therefore gained elevated privilege permission, okay, a permission that usually only a system app has. You can obtain it from Google Play, or in many cases, it will even come pre-installed on your device. It was designed to take commands and communicate with other applications on the device. But because there is no native way to verify the other app identity, each vendor needs to reinvent the verification mechanism every time from the beginning. And I think that Austin Powell summarized it the best. I think that, okay, thank you. So I now let Avi to explain into what we found.
Okay, thank you, Ohad. So what did we find? So we started analyzing the various MLST vendors. And the first one was TeamViewer. TeamViewer, I'm sure you know the name, is a very popular MLST vendor and has millions of downloads in the Google Play Store. So if it's vulnerable, it could impact millions of Android devices. So TeamViewer, as I said, is a main player and collaborates with all of these OEMs, LG, Samsung, HTC. So think about it, if we have an issue here, we can impact most of the interesting Android devices on the planet. But TeamViewer didn't collaborate only with these OEMs, but also with all of these. This is a screenshot from the Play Store, and every square is a different vendor. So it's a lot of vendors, meaning a lot of Android devices. So let's do a quick recap of the plugin verification mechanism. So a plugin, what's a plugin? It's an APK, it's an exported service. And any app, the way Android is built is that any app can connect to an exported service. And now it's the plugin's job to verify the identity of the connecting app. There's no native way to do it. And this is the code that every vendor reinvented. So let's go over TeamViewer's code. I'll give you a second and try to think what's not right here. I'll give you a hint, and I'll give you another hint. So what you can see here is that the plugin sets a hard-coded number, and then what it does, when an app connects to it, it extracts its certificate, the certificate of the connecting app, and then it gets the serial number of the connecting app and compares it to the hard-coded integer, hard-coded number. And if it's equal, it lets the app control the plugin and do privilege actions. So the question is, what's the serial number? So we went to the X509 RFC, and we can see that a serial number is an integer assigned by the CA to its certificate. Okay, that's interesting. But the question is, who's the CA on Android? Who creates certificates for applications? How do we sign them? So I'm sure you know that in Android, every developer is actually his own CA because we use self-signed certificates in order to sign the apps. So this means I can create a certificate and I can set the serial number and then sign an app with the certificate. So I can do just this, generate a certificate, set the serial number to the serial number which will match the hard-coded serial number, sign the app with, and boom, I'll have control of the device. So let's show you a demo. Okay, 1 second. So, what are you seeing on your, is it your left? Yeah, it's your left. So, what you're seeing on your left is the CNC server, malicious CNC server, and on the right is the device. The device has already pre-installed the TeamViewer's plugin. And now, what I'm going to do is install an app. It's on the device, but as you will see in a second, it's not a suspicious app. It could be from the Play Store as well. And it doesn't require any suspicious permissions, only SD card and full network access, nothing, which will raise any suspicion. I'll install the app. Open it. And once I hit the light button, boom. As you can see, I have from the CNC server the screen of the device. So think about it. Now I can see everything the user does. It's pretty powerful. If the user will now, open up his emails, type in passwords, everything he does, I can see. Even if the user uses secure container encrypts the data on the storage, but it's plain text to the user, so we can read the data. So I can as well read the data. I can do everything the user does. So not only I can view, I can also control the device remotely. So let's just, for example, open the call log. One click, and it will take a few seconds. I have a little bit of lag, but as you can see the log, and I will see it again from the CNC server. I can now go to home and maybe type something. Maybe I'll search for something interesting. There's something interesting to do here in Vegas. So it'll take a second, and I'm not on the. Well, it should be a low, but you had me at a low. Well, okay, great. So this is the first demo, and I'll get back to the rest. Okay. So quick recap. So these plugins have two very important permissions: get the screen and inject user events, simulate user actions. These are wildcard permissions. Two permissions to rule them all. I can now do everything I want on the device using only these two permissions. I can install more apps that do other stuff. I can have complete control of the device. So this means I can bypass almost every Android security mechanism because I'm the user. And also, secure containers here, it means that they're just not enough, because if I have access as the user, I can access everything in the secure container. So let's continue to the next tool. So we decided to view All Support. Why All Support is an interesting vendor? Well, they also collaborate with very big OEMs, LG, Samsung, Huawei, Oppo. But in this case, the plugins here, we found that in a lot of flagship devices, variants of flagship devices, the plugins are pre-installed, meaning that the devices come vulnerable out of the box. Not only that they are coming vulnerable out of the box, think about it. I said earlier that the plugin is an exported service. This means it doesn't have any launcher menu, a launcher icon, so the user won't even know that there's a plugin installed. And because it's part of the system image, the user can't uninstall it. He can't do anything. He has to wait for an update by the OEMs. So it's a very tricky thing if we'll find a vulnerability here. So let's go over All Support's code. This time, no hints. So what does the All Support do? Is again waits for an app to connect and gets the certificate, but this time instead of extracting the serial number, it will use a hash code function on the certificate. Okay, so and after taking the hash code, we would compare it to a hard-coded number. So hash code. Well, a hash, this sounds a lot better, you know, sounds secure, a hash. But what's a hash code? Is it an MD5, SHA-1, maybe a SHA-256, or even CRC32? So lucky us, you know, Android is open source, so we can just go over its implementation and see. So going into the code, we saw that the signatures object, that's the certificate object's hash code function, calls the arrays hash code function. And going to the arrays hash code function, we can see that it does a quick calculation and then returns a 32-bit signed integer. And if I'm sure that some of you recognize that this is the default Java's hash code function. So as you probably know, returning an integer has only 4 billion possibilities. That's not too much. We wrote a simple script at home that generated a lot of certificates, and after some time, a few hours, we got a certificate that matched one of the hard-coded serial numbers. So again, we could sign the app with this certificate and connect to the plugin. So again, I won't show here a demo. It's very similar to the TeamViewer's one, and we want to show something more interesting. So what else? So we found multiple vulnerable plugins. This I just went over to. We didn't check them all. There's a lot more to do. You can do it at home. And it's important to understand that this issue is not limited to MRST vendors. What we talked about here is that there are apps, third-party apps that are signed by the OEMs, and that they can't verify the identity of other apps because Android doesn't supply a native way to do it. Meaning if there are other apps that are signed by the OEMs, and they can have as well these issues, so you can check this out. And it's also important to know that because the plugins are signed by the OEMs, this creates a big issue, because an app that's signed by an OEM certificate, this means that this app cannot be revoked, because there are a lot more apps on the phone that are signed with the same certificate. So if I revoke the certificate, the phone will just stop working properly. So there's no simple way to mitigate this. And think about it more, even in a year from now, because I can revoke the certificate. If an attacker will get a hold of an old vulnerable version, even after a new fixed version will be out, it could just persuade the user to install it and install a vulnerable plugin and attack it, because this thing is not going away. So okay, I'll call Had.
Thanks. Can you hear me? Can you hear me?
Yes.
Okay, great. Okay, so I think that what we saw was already pretty impressive. But when we investigated different MRST tool, we saw that there maybe be another angle to attack this kind of tool. And what we saw that maybe there is a way to manipulate the main app business logic and therefore also gain full control on the mobile device. And what I'm going to discuss now is a Communitech, sorry. Communitech is another MRST vendor that was signed by many vendors and actually come pre-installed on some devices. And when we start to investigate, we saw the following behavior. So Communitech main app is accept SMS command that that you can change the setting without them. And one of the interesting command there is that you can change the subdomain of the CNC server instead of the original subdomain of the command. And what is even more severe is that you can change the subdomain without any authentication, which means that I can at least send the app to work with an invalid CNC server and therefore cause the application to stop working. But the checkmate here was that we saw that the app doesn't sanitize the subdomain properly, which means that I can just add another slash to the domain and therefore send the app to work with a completely different CNC server. In my case, the attacker or the malicious CNC server. So just to recap what I just said, so an attacker can change the CNC server to a malicious CNC server, which is with a single text message without any user intervention and take full control of the device. So let me show you a short demo. Second. Okay, so again, I have here the device that has this application installed, and I'm just going to send the malicious text message to the device. You will see it appear quite quick, hopefully. Let's hope that the god of cellular network. Okay, great. And as you will see in a second, so I got new message and Communitech was open and acknowledged that it got command to change, the CNC server. And of course, but from now on, because I have full control of the device, of course, my next action will be to just send the home button. I didn't explain, but this is in this demo, we didn't invest the time to also show you the screen and everything, but it's the same principle, and of course, it can be done. And this is the CNC server that I'm using to control the Communitech device from now on. So of course, my next action will just to press home in order to take the device, and make sure that the user won't be able to see that something happened. I can, for example, send command and open the call logs. I can, for example, query the list of apps on the device. So let's see if there is maybe another vulnerable app. And of course, again, just an example. From that point on, I took complete control on the device with a text message, which is, of course, very, very interesting for an attacker. Okay. Okay, so let's say, so in terms of a vulnerability disclosure timeline, so we reported to all to Google, the OEM, the vendors about these vulnerabilities at mid-April. We got responses for most of them. Since May, we saw that some of the vendors already start to publish new version, and we know that some of the OEM, like Samsung, already also working on fixes in their versions. But in August, we are still waiting for some of the vendor responses. Okay, so let's conclude. So Android ecosystem is flawed, okay? As you just saw, an attacker can take full control of your mobile device. And what is even worse is that currently there is no way to patch it. And this problem affects hundreds of millions of Android devices around the world. So what should you do? If you're a technical person, so you can go to our blog after this presentation and check if your device is one of the vulnerable devices. And if one of your devices is vulnerable, has the vulnerable plugin, you should remove it, again, if you can. Because unfortunately, if it's come pre-installed on your device, you cannot do it. But because this is for technical persons, we also encourage you to take a much more robust security approach and have a layered mobile security solution in your corporate. The first layer should be a vulnerability assessment. You should have a layer that continuously monitor the different devices and application on your device and check if they are vulnerable to any types of vulnerability. And as the last week showed us, there is new vulnerability that are getting discovered all the time. The second layer should be a threat detection that will be able to detect if one of the applications or on your device is able to attack, to exploit one of these vulnerability, and it's something that they should keep monitor all the time. And the third layer should be a risk mitigation layer, that should be able to help you to notify the user if something happened and to continue to monitor the patching cycle in your corporate. But until then, what we did, we created a light version of our system, which you can download for free for Google Play, and it will help you to scan your device and see if first your device is vulnerable, and more than that, if your device is currently under attack, if there is another application that tries to currently exploit your device. Okay, so any questions? Thank you very much. Any question?
Question?
I think it should be, yeah, in a few minutes.
Yeah.
Yeah.
Is it not possible to simply set up a secure communication over the unauthenticated binder?
Well, the problem is that not this secure communication, because binder doesn't just supply a native way to do it. If you do it correctly, even without Android's native support, it will be okay. But the problem is, Android didn't left a choice for developers, to introduce a verification code themselves. And once you probably know, you do a security check yourself. A lot of the times when you try to invent something, you do it badly. So that's it.
But you know exactly which apps are need to talk to each other. You can hard code the certificates.
Yeah, but you need it. You can do it, but you need to do it yourself.
Right.
What we found that most of the vendors didn't do it correctly. So that's what amazed us.
Okay, thanks.
Okay. Any other questions? Yeah. So we got response from the vendors, and they are releasing new versions for most of them. As we said, not all of them, and they are releasing new versions of the plugins. Yes, there was a question here. Yeah. Yeah, there were a few that did it correctly, but they were the minority of vendors, not all. Well, no. Sorry not to, I'm not sure. Yeah, maybe I missed it, so. Well, all the information will be in our blog for what we found vulnerable. We're not keeping a list for patched versions. Yeah. Well, I don't think we have a link here. It will be.
I think it's through the app. You can get to the blog.
Yeah.
Through the scanner app, you can get to the blog.
You can just Google checkpoint certificate and you'll get there. Okay. Any other questions? Yeah.
So how do you distribute this malicious app through the store? Doesn't Google sign all the store apps?
Well, if you think about it, it's not a malicious app. It's an app that uses the plugin just as the main app, the vendor's main app, and sends it to a malicious server. It has a malicious intent, but what it does, it's not malicious. So there's no way, if you don't have something that knows the intent of the app, how can you know it's malicious from the start?
But doesn't Google control the certificate used to sign the app when you ship through the store?
Google?
No.
No. Any more questions?
Okay. So thank you very much.
Thank you so much.
Yeah.